Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is set number 1 of 5 good problems on the chapter of direct and inverse variation. I have already covered the theoretical aspects of this chapter from the textbook of author R.S. Agarwal in the other playlist, that is CBSE Maths 8 R.S. Agarwal, and have solved all the problems from the textbook exercise problems. If you have not watched those videos, then I strongly suggest and request that you watch those videos also to have a good foundation of the concepts of this chapter. This video is part of the playlist Maths 8 HOT, where HOT stands for High Order Thinking Problem, where I come up with relatively harder problems of every chapter as and when they are completed in the other playlist, that is CBSE Maths 8 R.S. Agarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving 5 good problems of set 1 on the chapter of direct and inverse variation. Okay, so I have the sorry, I have all the questions of the. Now this PDF is saying 10 good problems. It was prepared much earlier when I used to solve 10 good problems, but now I am solving 5 good problems to make the video shorter. So even though this PDF has 10 problems, I will solve the first 5 problems from this PDF. This is set number 1. In the set 2, I will solve the remaining 5 problems. I hope you can properly see the questions of the PDF on the left hand side, even though it might look a little smaller. I hope you can anyway make it out the writings. Okay, now let's start solving the problems. After solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution if you think it will help you. Okay, question number 1. Let me quickly check if everything is properly visible or not. Okay. Question number 1 says that in a camp, 120 men had provisions for 75 days. After 5 days, 20 more men joined the camp. For how many days did the provision last now? So, this is a problem based on men, food means provision, and the number of days that the food lasts depending on the number of men. Now always remember, in this kind of problem the food or the provision is always a constant. So when it says that 120 men had provisions for 75 days, it means that whatever the food is, it will remain constant. The food is not being added or removed, it is constant. The amount of food will be constant. Now based on this fact, so that food can be consumed by 120 men in 75 days. That is, the food will last for 75 days if the number of men is 120. So if we consider the two quantities as x to be the number of men, and y to be number of days, the provisions last. If these are the two quantities that we need to focus on. So x is the number of men and y is the number of days the provisions last. Okay. Now definitely we know that these two quantities are inversely proportional to each other, or these two quantities x and y are in inverse variation. So we can say that y varies inversely as 1 by x. We can also say it means the same thing. X varies as 1 by y. It does not matter. These both these two variations are same. That is, y varies inversely as 1 by x, or x varies inversely as 1 by y. These two things means the same thing. Eventually, so when two quantities x and y are in inverse variation, we know that their product is a constant. So x y will be a constant. That is, any corresponding values of x and y, of the quantities x and y, it will be a constant k, where k is the constant. This constant k is known as the constant of proportion or variation. Okay. Now it is saying now it is saying that after 5 days 20 more men joined the camp. After 5 days 20 more men joined the camp. For how many days did the provision last? Now after 5 days, what is the scenario after 5 days? After 5 days, the scenario is that the number of men is the same, that is 120 men, but in 5 days definitely these 120 men have consumed some amount of food. So the amount of food has been consumed in 5 days. So whatever food is left, that food should last for another 75 minus 5 days, that is 70 days. So so the scenario after 5 days is that 120 men can survive. 120 men have, you can say, have provisions for 75. The total amount of food initially, it would last for 75 days, and so after 5 days some amount of food is consumed. So definitely after that amount of food is consumed, the remaining food should be consumed. The remaining food should be enough to consume for another 75 minus 5, or 70 days. So this is the scenario after 5 days, that there is food available, so that 120 men can last for 70 days. Okay. Now it is saying that 20 more men joined the camp. So 20 more men joined the camp. For how many days did the provision last? Now, okay. Let's say let the provision let the provisions, that is the provisions that was left after 5 days, let the provisions lasted for y days. Since the quantity y, we have assumed the quantity y to be the number of days and x to be the number of men. So let the provisions lasted for y days, 5 days. So this is, all these are happening after 5 days. So after 5 days, we know that 120 men have provisions for 70 days. Now if the question is, if 20 more men joins the camp, then for how many days the provision will last? So we are assuming that let the provisions lasted for y days when 20 more men joined the camp. So we have now two data. This is the first data and this is the second data. Now if we tabulate, if we create a table of the quantities x and y, now these data are all based on after the 5 days. So first we have that 120 men have provisions for 70 days. So we can write 120 as the quantity x and 70 for the quantity y. Now the second data will be, we are assuming that after 5 days, whatever provision was left, that lasted for another y days. So we will write y here, not y, but y1. This should be y1, not y, because y denotes the quantity. So whenever you assume some corresponding values of x, it should be always x1 or x2 or x3. Similarly, when you assume some values of quantity y, it should be y1, y2, y3, like this. So we have the second data is that the number of days the provision last is y1, whereas the number of men will be 120 plus 20, because after 5 days 20 men more men have joined the camp. So this is 140. Now we apply the concept of inverse variation, that the product of the corresponding values should be a constant. So we must have 120 multiplied by 70 should be equal to 140 multiplied by y1. So this implies y1 is equal to 120 multiplied by 70 divided by 140. 0 cancels, 260. So 60 days. So after 5 days, when 20 more men have joined the camp, the provision would last for 60 days. So the correct choice is B. B is the correct choice. Okay, let's do problem number 2. If x varies directly varies with y, so this means that x varies directly with y, or x and y, the quantities x and y are in direct variation. From the table below, find the value of, so a table is given. Let's quickly write the table. X, y, we have 8, we have 14, x, we have x1 and y1. So this is the given table, and it is asking to find the value of, we have to find the value of 7x1 plus 6y1 divided by 14x1 minus 3y1. We have to find the value of this expression. Okay. Now, since the quantities x and y is given to be in direct variation, we know that x by y, the quantity x by y, the ratio of the quantities x and y, that is x by y. So this implies, we can say x by y is a constant, this which is known as the constant of variation. So will be a constant. So now we can say, using the corresponding values given in the table, we can say that 8 by 14 should be equal to x1 by y1. So this implies, if we do cross multiplication, we get 14x1 is equal to 8y1. Okay. Now you can do a little bit of simplification of this equation, that is 14xy is equal to 8y1. I can divide both the sides by 2, and I get 7x1 is equal to 4y1. 7x1 is equal to 4y1, and also we know that 14x1 is equal to 8y1. So this expression now becomes 7x1. We will replace in the given expression, we will replace all the x1 with the corresponding y1. That is, we will replace the value of x1 by its corresponding value in terms of y1. So we know 7x1 is 4y1. So we have 4y1 plus 6y1 divided by 14x1 we know is 8y1, 8y1 minus 3y1. After simplification, this becomes 10y1 divided by 5y1. So y1 cancels out and this is 2. So the value of the given expression, that is 7x1 plus 6y1 divided by 14x1 minus 3y1 is 2. So the correct choice is A. A is the correct choice. Okay, let's do the next problem. Problem number 3. Sita buys 4 liters of oil every month with her budget of rupees 500. Okay. How many liters of oil will she be able to buy with the same budget if the price per liter rise by 25%? Okay, so 4 liters of oil Sita buys every month with her budget of rupees 500. That is every month the amount of money so 500 rupees is all she can spend in a month. That is she cannot buy oil whose cost will be more than 500. It has to be 500. So now if the budget is the concept is that if you have a fixed budget, then the amount of oil, that is the liters of oil, and the price of the oil per liter, these two quantities will be in inverse variation, because if the price increases, you have a fixed budget is 500 rupees. If the price per liter of the oil increases, definitely you can purchase less amount of oil, and conversely if the price decreases, you can purchase more oil. So if I consider X to be the amount of oil. By the way, when you are considering the two quantities X and Y, you should always specify the unit. For the first problem, I think the unit, there was no unit. I mean, X was the number of days, so which is basically a number, which is basically an integer number, and a Y is also a number. So there were no unit was required for problem number 2, and also problem number 1. Okay, and also problem number 2 was basically some conceptual problem. So now in this problem number 3, X is the amount of oil. This is in liters, let's say, purchased or bought, and Y be the price of oil, that is rupees per liter. So these are the two quantities we need to consider to solve the problem. X is the amount of oil bought per month, and a Y to be the price of oil per liter, that is rupees per liter. Price of oil is fine, price of oil. Now we can clearly say that X, the amount of oil, will be inversely proportional to Y. That is the quantities, these two quantities X and Y will be in inverse proportion. Okay. Now if we have to create a table, let's see how we create a table. It says that Sita buys 4 liters of oil every month with her budget of rupees 500. 4 liters of oil every month with her budget of rupees 500. How many liters of oil will she be able to buy with the same budget if the price per liter rise by 25%. Okay, so the actual price is not given. In the first line says Sita buys 4 liters of oil every month with her budget of 500. Now, what was the price of the oil when Sita was buying 4 liters of oil? It is not given. So let's say let original we have to assume the price of oil, and definitely the as an unknown variable, and this variable we need not solve it, it will eventually get cancelled out. So original price, let's say let original price of oil be, let's say, rupees X per liter. Now, therefore, it is given that what will be, how many liters of oil will she be able to buy with the same budget if the price per liter rise by 25%. Okay, so price of oil after 25% increase means 25% more. Now, this is the concept of percentage. I hope you will able to understand. If I write it, that price of oil after 25% increase will be 100 plus 25 divided by 100 multiplied by X. This will be the price of oil per liter after 25% increase. That is, the concept is 25% more. The concept applied is 25, this is a concept of percentage, 25% more of any quantity, let's say A, is equal to 100 plus 25 divided by 100 multiplied by A. Okay, so this is equal to rupees. If you simplify, 100 plus 25 is 125, and 125 by 100 is 5 by 4. So this will be 5x by 4 per liter. This is the cost of the oil per liter after 25% increase. Okay, now let's create the table. X and Y. Initially, it says that Sita buys 4 liters of oil every month when the price has not increased, that is the original price. So I can say, write 400 and the price of oil as rupees X, because this is what we are assuming, that the original price of the oil per liter is rupees X. So we have this data, these corresponding values. Now let's say now it is asking how many liters of oil will she be able to buy with same budget if the price per liter rise by 25%. So let's say we are assuming, once again assuming, let after 25% increase in price of oil, Y liters, not Y, but X1 liters of oil can be bought with same budget, that is rupees 500. Now rupees 500 is will not matter. This 500, this figure is not important to solve this problem. Instead of 500, it could be any other value. It is not used to solve this problem with, let's say, same budget. So the second data, corresponding values we will have is the price has now increased by 25%. The price has now become 5x by 4. Oh, sorry. I did let original price of oil be not X. We cannot use X because we are already assuming the X to be the amount of oil. So let's say the original price of the oil B, let's consider some another variable, let's say P, let's say P, rupees P per liter. So this will be not X but P. You can use any letter, but please do not use the letters X and Y. P, we have 5P by 4. So over here we must have P and 5P by 4. Now when the price is 5P by 4, that is price of the oil is per liter is 5P by 4, we are assuming the amount of oil that can be purchased in the same budget is X1 liters. So we have X1. So now let me move this a little above. So now we can say, since these two quantities X and Y are inversely proportional to each other, we know that their product will be a constant. This is the main concept of inverse variation. So now from the table, using the corresponding values, we must have 400 multiplied by P is equal to X1 multiplied by 5P by 4. So PP cancels out from both sides, and we have X1 is equal to 400 multiplied by 4 divided by 5, and this is 320 liters. 320 liters of oil can be purchased when the price per liter of oil has increased by 25%. So why the choices are 3.2, 4.8 liters? Why? Sita buys 4 liters of oil every month with a budget of 500. How many liters of oil will she be able to? Oh, sorry, this is not 400. My mistake. This is not 400, but this is 4. This is 4. So this is 4. This is my mistake. That was 4 liters. Okay. So 4 into P is equal to X1 multiplied by 5 by 4. So X1 is equal to basically 4 multiplied by 4 divided by 5. This much liters of oil. This is equal to 16 by 5 liters, which is equal to 3.2 liters. Now, if I am doing any kind of calculation mistake, there is high possibility that I will do some calculation mistake and will come up with the wrong answer and select the wrong choice. If that happens, please let me know in the comment section. I will highly appreciate that. So the answer should be 3.2 liters, and so the correct choice should be choice D. The correct choice is D. Okay, let's do problem number 4. If X varies inversely with Y, then which of the following quantities remain constant? Okay, so we are given X is varying inversely with Y. So we write it in mathematical notation, we write it as X varies. This is the symbol of varies. So X varies inversely with Y. X, this is the notation of X varies directly with Y, and this is the notation for X varies inversely with Y. So we are given this. So from here we can say, from the concept of when two quantities X and Y are in inverse proportion, we know that their product is a constant. That is, all corresponding values of the product of all corresponding values of x and y will be a same constant. So let's say the constant be k. K will be a constant. Now we need to check whether all the given choices, we have to see whether we every choices we can simplify based on using this fact. We can simplify all the given choices to be a constant, that is independent of x and y. So let's see what is a choice A, x by y, x by y. Now x by y, we cannot simplify this expression x by y to make it independent of x and y. To independent of x and y means we cannot simplify it to an expression where it will not have x and y. Now if you try, if I what can I do now? X, if I try to replace x with the value k by y. Now from here I can say that x I can say is equal to k by y. Now if I use this x equals to k by y, then we have x by y is equal to k by y multiplied by y by 1 by y. So we are still having y square. So this expression is not independent of x, independent of y. So it has y. So if you try to simplify x by y and replace y by k by x, then also it will have the x. So this expression x by y cannot be simplified to a form where to a value or expression where it will not have x and y. So this cannot be expressed independent of x and y. So this implies x by y is not a constant. This is not a constant. So definitely this is not the correct choice. Let's see the choice B. Choice B is x plus y. Definitely x plus y, you cannot also this will not be, you cannot simplify this expression x plus y to a form where it will not have the quantity x and y. We must, the quantity, when the question is then which of the following quantities remain constant. Remain constant means you have to which of the following quantities can be expressed as a constant, that is in terms of k, and maybe any other constant values, but it should not contain the quantity x and y. So this x plus y, definitely we cannot express it as a we cannot simplify it to a form where it will not have x and y. So this can be written as k by y plus y. So this is definitely contains x, contains y, even though it does not contain x, but it contains y. So this is not independent of, not a constant, that is contains y and not a constant. Now if you try to simplify x plus y as x plus k by x, then also we see that it contains x, and hence not a constant. So no way, no matter how much you try, you cannot express x plus y in a form that will not contain the quantity x and y. So x plus y is not a constant. Choice C is 1 by x square y square. 1 by x square y square. Now this is equal to 1 by xy whole square. This is equal to 1 by xy we know is a xy is a constant. Since x and y are inversely proportional to each other, we know that xy is a constant, and we have already assumed that let the constant, the product xy be the constant k. So we can say that 1 by xy whole square is 1 by k square. Now if this will be, you can consider this as another constant k1, where k1 is equal to k 1 by k square. So this is a constant. This is a constant because k is nothing but 1 by k square, and k is a constant. Constant as k is a constant. So this implies that 1 by x square plus y square is a constant. So definitely the correct choice should be C. Definitely D is also not a correct choice because D is quite similar to A. So the correct choice is C. C is the correct choice. Okay, let's do problem number 5. Problem number 5. Shushmita have enough money to buy 9 kg of onions at rupees 5 per kg. Shushmita have enough money to buy 9 kg of onions at rupees 5 per kg. Okay. So basically, if she can buy 9 kg of onions at rupees 5 per kg, so the cost of 9 kg of onions is rupees 945. So Shushmita might have is having rupees 45. Now how much onions can she buy if the price is increased to rupees 12 per kg? I think this question is very similar to question number 3. In fact, this question is a little more straightforward, even though the pattern of the question is same as 3, but this question is more straightforward. So we can clearly understand that the amount of money Shushmita have is fixed, it is not changing, which is basically 9 into 5, that is 45 rupees 45. Okay, so if we consider the quantities x as amount of onion bought, that is in kg, and y to be the price of onion, that is rupees per kg. Per kg, price of onion per kg. Okay, so we can clearly now say that if you have a fixed amount of money to purchase some onion, then that money is fixed, then obviously you can purchase less amount of onion if the price of the onion increases, and you can purchase more amount of onion if the price decreases. So we can say that then these two quantities x and y will be inversely proportional to each other. That is, their product will be a constant, that is corresponding values of these two quantities will be the same constant, which is known as the constant of variation or constant of proportion. Now let's, based on the given information in the problem, let's create a table. So first it says that Sushmita have enough money to buy 9 kg of onions at rupees 5 per kg. So when the price of onion was 5, that is rupees 5 per kg. The amount of onion Sushmita was purchasing or was able to purchase was 9 kg. So we have 9 and 5. Now it is asking how much onions can she buy if the price is increased to rupees 12 per kg. So let's assume x1 kg of onion can be purchased when price is rupees 12 per kg. So we can enter the corresponding values in the table, and we have rupees 12 for y and x1 kg for the x. Okay, now applying the concept of the fact that the product of the two quantities x and y will be a constant, we can say that 9 multiplied by 5 should be equal to x1 multiplied by 12. So this implies x1 is equal to 9 multiplied by 5 divided by 12, this much kg. Okay, and this is if we simplify 3, 3, 3, 4, this is 20 by 4 kg. 15. 5, 3 is 15. 15 by 4 kg, which is equal to 3 and 3/4 kg. 3 and 3/4 kg. So this amount of onions can be purchased when the price of the onion is rupees 12 per kg. So the correct choice is C. C is the correct choice. So this brings to an end in solving 5 good problems on the chapter of direct and inverse variation. I hope these set of problems will give you a good idea of how to apply the concepts to solve this kind of problems. And in the next set, set 2, I will continue solving the next 5 problems from this PDF. So please stay tuned for the next set of 5 good problems in the next video, that is set 2. So if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Also keep an eye on the other playlist, that is CBSE Maths 8 RS Agarwal, where I will soon start the next chapter, that is on polygons. I will end the video here. Thanks for watching, and until the next video, take care and bye.